Right, here we are, domain 10, your final domain in the CISSP common body of knowledge. And what we're going to do here is, as before, no fluff and get to the point. If there's anything that you have to do additional, I'll mention that, because it's your objective to ensure that you actually understand and know everything. It's not a parrot fashion and not just theory as well. So let's actually have a look at what the Candidate Information Bulletin says from IC Squared. It says that the physical environmental security domain addresses the threats, the vulnerabilities, and the countermeasures that can be utilized to physically protect an enterprise, resources, and sensitive information. These resources include people, the facilities in which they work, and the data, the equipment, support systems, media, and supplies they utilize. Physical security describes measures that are designed to deny access to unauthorized personnel, including attackers from physically accessing a building, facility, resources, or stored information, and guidance on how design structures to resist potentially hostile acts. The candidate is expected to know the element involved in choosing a secure site, its design and configuration, and the methods for securing the facility against unauthorized access, theft of equipment and information, and the environmental and safety measures needed to protect people, the facility, and its resources. Now, taking these items in consideration, we need to look at physical security objectives. Now, when we look at physical security, it is really our first line of defense within a data center. However, when we put down Wi-Fi access points without authorization and without going through a process, it does extend our perimeter and does increase the threat to our environment without considering. We've done war drives as well, whereby a person within a logistics environment wants to put down a wireless access point to ensure that his handheld scanners can talk to the network, but at the end of the day, adding it into the network, he exposed the whole network from the outside due to the wireless access point being a bridge and allowing anybody in. We will look at facility design, location and management, electrical supplies and the faults, physical intrusion detection, fire prevention, detection and suppression, threat modeling and risk management, which is the first step that we have to do, human resources management, such as guards as well. Now, part of an asset environment, asset-centric, we need to look at threat modeling. A security development lifecycle, or SDL, includes the following steps. We have to identify all the facility components. We have to identify any external dependencies on those components. We have to identify then any physical threats to the components, assign a risk value, determine any countermeasures that we should apply and have applied, and that will give us our inherent and resultant risk. We need to do this continually to update the threat model based on the emerging security landscape. Now, also, different threats do exist to physical security, and they can include natural or environmental threats. These include things like earthquakes, floods, tornadoes, snows, sandstorms, and the consequences of these threats may include issues like riots, circumstantial market fluctuation, a run on banks, we've seen that as well, utility systems, water and fire, heating, ventilation and air conditioning, and also then man-made or political events such as strikes, disgruntled employees, terrorism, riots, and also sabotage. Now, other malicious threats include sample sources such as hardware theft. Hardware may be the target, but the data may be included. There can be espionage, things such as tenders and business drivers. You've seen them, the legal and investigation section, such things as the Anton Pillar order. Dumpster diving. Dumpster diving can be legal or illegal depending on if the person performing the dumpster diving is trespassing. There's issues like social engineering and shoulder surfing. Now, social engineering is actually one of the easiest way to compromise good security due to the human factor. Also, heating, ventilation, and air conditioning access threat could be sabotage. Now, the primary concern with physical security is definitely life. As is in the case of disaster recovery planning and business continuity planning, life is the number one priority. Design consideration, such as fail-safe, which means that when the power is not there anymore, the device is unlocked. Evacuation procedures. It is easier to replace a system compared to a human, of course. And again, if you don't do your due care and due diligence, legal issues may arise. In this picture on the right-hand bottom here, we can see a safe in a bank in America where we had a tornado, and what the bank staff has done is actually moved into the safe with the clients and locked them in there. So they survived and actually, as part of physical security, taken some action there. Looking at information security from a physical security point of view, we need to have key areas of knowledge, and these are understand site and facility design consideration as the initial point. We need to look at the facility design such as a layered defense model, also known as defense in depth. And what happens, we can either start from the inside to the outside or from the outside to the inside. Here, well, let's look at visual markings in a building. Is it present or not? Sometimes we don't want visual branding outside of the building because we don't want people to know where a secure facility is located. We can look at a building perimeter, external perimeter, the lights outside. We can look at empty or dead areas where no people should be walking, and there normally is intrusion detection in those areas. We look at an external fence, and then also access control points through each layer of the defense. Now, sometimes we see a problem with physical and logical security management. They do not communicate. However, some communication channels should exist between logical security and physical security management. It will ensure that current and future design considerations are met. Also, an instant correlation between logical and physical security will benefit. This means that as soon as a physical security, as an example, sees that there's a lot of possible intrusion attempts outside, they can communicate with the internal logical security management to ensure that the data is secured. Also, it would be nice to actually have logical security, physical security, business risk, and group risk reporting into a central matrix reporting mechanism known as Group Risk Office. A very good example here is sometimes over the weekends I take a drive and actually look at physical security designs, what companies are doing. And here is within an industrial environment, there's a petroleum depot. And as you can see in this picture, on the left-hand side, totally on the left-hand side, there are cameras. Now, cameras are adequate. They actually point you to all the areas. Cameras are viewing cameras. We have adequate lights in the environment as well. The wall is fairly high for people not to scale, so it's over the 6 feet. We'll see later as well. However, as you can see here, right in the middle, we've got a telephone pole very close to the wall. Now, this is a telephone pole that has been decommissioned due to the fact that now the guys are actually either using wireless or some other service provider, and as in South Africa, as we are here, we have a lot of problems with copper theft, so the cable could have even been stolen. However, here, the pole is too close to the wall. A lot of security designs are adequate, but a person can use this pole to scale the wall easily. So it actually creates an avenue for an opportunistic thief or perpetrator to actually scale the wall. I do not know what's on the other side. I didn't have a look there. However, this just indicates that the physical security management is not doing an adequate job to go around the facility to ensure that any weaknesses are addressed. And you'll see it later as well with CPTED. Another example I've seen as doing my driving as well is this telephone or communication pole that actually is outside in the facility. And what they've done, as you can see here, they've put a lot of barbed wire or blade wire around this pole for people not to scale it to get over this palisade fence as well. It is effective. Usually it indicates that something happened before the time as well. But when you actually speak to the service provider, if this was done by the person owning the property, it would be an illegal issue as well. On the right-hand side bottom, you can see this example here as well. In this facility, we had youngsters scaling the wall late at night because they couldn't find the key, and management placed some barbed wire, as you can see there, reactively as well. However, any person that would like to scale the wall, that would not act as a deterrent. So visually it's nice, but practically it's not effective at all. Now also the goals of physical security include the following: deterrence or prevention, which is the discourage of the likelihood of a threat to be realized. There's a delay that we want to create, which makes the compromise time consuming, which increases the success rate of detection. The detection itself, which is dependent on some clipping levels, threshold or exceptions, that is a level that we set. The assessment is to determine the impact on business and systems and consider BCP, which is business continuity planning, or triage. That is where we decide which systems to carry on or which to actually stop or not use anymore or decommission, and a formal compensating controls. There's a human response which invokes the formal incident management process to minimize unauthorized disclosure, destruction, and modification. There's a recovery as well. One of the goals to bring back the system to normal operational state. Then there's different categories of the security controls. We have administrative controls, we've got physical controls, and then also logical or technical controls. Administrative controls include things like policies, standards, procedures, baseline, and guidelines. For example, keeping equipment well maintained, security and fire rules, these fall under administrative controls. Physical controls include things like infrastructure protection. These are physical items such as locks, doors, walls, fences, aesthetic barriers. Also, security guards patrolling the area, dogs, guard rooms, and control points as well. Then finally, we have logical or technical controls, which is access controls, identification, authorization, biometrics, monitoring, and lights. CCTV, intrusion detection, intrusion prevention systems, fire detection and suppression systems, also UPSs and generators. We've got heating, ventilation, and air conditioning, also known as high voltage alternating current. There are types of security controls which include issues like directive controls. These are often called administrative controls, and these are intended to advise employees of the behavior expected of them. An example of a directive control is the acceptable use policy, which every user has to sign, of course. There are preventative controls before the event. These are physical, administrative, and technical measures intended to prevent actions violating policy or increasing risk to system resources. We have deterrent controls, which is a goal to reduce the likelihood of a vulnerability being exploited without actually reducing the exposure. A detective control, which is during the event, involves the use of practices or processes and tools that identify and possibly react to security violations. Corrective controls after the event, which involves physical, administrative, and technical measures designed to lessen the probability of the exploit being realized. Then finally, we have recovery controls. Once an incident occurs that results in the compromise of the integrity or availability, the implementation of recovery controls is necessary to restore the system or operation to a normal operating state. Also, when we look at any of the security environments, this is in physical security, of course, we look at FIPS 140-2, or the level of effort. These are extrapolated, and we can actually say it's things like the time required to conduct the attack, time to develop specific attack methods, tools, and skills, which is referred to as non-recurring labor. Think about a syndicate here that actually would like to steal money from a bank. So they have to look at how the processes work, get staff involved, and this is the whole process, and they have to develop this. And it's only for this specific attack, and that's why it's called non-recurring labor. The formal education of the hacker is definitely an issue here. The skill and practice of the hacker, the availability of capital equipment, expert or unique resources as required for the attack, and also the risk of failure or probability that the attack will not be successful, which possibly may result in detection. So this is all to do with the level of effort. The next section is the support of the implementation and operation of perimeter security. Now, when we look at crime prevention through environmental design, the facility, location, the construction, and management using crime prevention through the environmental design is really important. And there are, as some of the documentation defined, three major components, but I've broken it down here into the fourth one due to the fact it's the latest study of CPTED. These issues like natural surveillance, see and be seen. A person is less likely to commit a crime when he thinks that someone will see him. There's territorial reinforcement, clearly marking a private and public areas to discourage any potential trespassers. There's natural access control, where the goal includes controlling the flow of people using, for example, fences, pathways, signage, and landscaping. And then finally, there's maintenance. It's a new component in here, also known as a broken window theory. If allowed to exist, will lead to more broken windows and result in urban decay. More broken windows here possibly being a trespass of unauthorized users. A very good example here, top left here, we can actually use natural thorns from a tree, for example. This is a natural design. And then also on the right-hand side bottom, we can see bollards being put in to make sure that people do not park on the pavement, to ensure that pedestrians use it as a walkway. As I said, sometimes weekends drive around, and here I saw a perimeter fence. Left-hand top, you can see some effort. We have our fence. We have some barbed wire at the bottom on the inside. We also have barbed wire a little bit to the top. And then finally, right at the top, we have a whole spiral of barbed wire to make sure that people don't come in or out here. So it seems like it should be fairly secure. However, just a few meters away from there, we have a hole in the fence that hasn't been fixed for a while. This, to trespassers, would indicate that we don't have perimeter control or review, and we can go in and out as we can please. So by not fixing, more intruders are invited. Now, part of the defense in depth, the layer defense. Security through layers of controls. There are definitely multiple layers which a trespasser has to pass through everyone. It starts with the perimeter, then the building, the grounds, and the building entry points, etc. However, we can have things like right on the outside. Here we're starting from the outside to the inside. We have fence and associated lights. We have electronic motion sensors inside the fence. We have security guards on the perimeter. We have biometric access control, server monitoring, and then finally video monitoring of the whole environment. Now, when we design physical security as well, we have to consider a couple of things. For example, heating, ventilation, and air conditioning. Are there any redundancy requirements, such as generators? Construction materials of the walls and ceilings. Are they fire retardant? What is the close proximity environment? Power distribution systems, such as multiple grid and data centers. Communication items such as copper, telephone wires, and fiber optics. Now, often in countries, theft is an issue with copper. Rodents also have an affinity for Kevlar around optical fibers. So if the copper is replaced by fiber, you may have a problem with rats, rodents chewing through your cables. Surrounding hazardous materials, what's our neighbor storing? Is it fertilizer, which is equates to solid rocket fuel? Exterior components such as urban decay is in a safe environment. Topography indicates how high we are, at what level, where we located, close to any flood areas. Proximity to airports, we need to consider highways and railroads. Because we do have highways and railroads, there's a possibility that Trucks could carry hazardous material, potential electronic interference, climate, swell. Are there any sinkholes around us? Existing fences, of course, detection centers and cameras and barriers. What has our neighbors done? Vehicle activity. Is it during the week the same as weekends, end of month, end of year? Neighbors in crime and also possibly close to a military base as well. These are all exterior components we need to consider. Now, also, when we look at fences, there are federal, state, and local codes that may apply. However, obvious things like no parking should be allowed near fences because the trucks, lorries, or cars, whatever, can be used as a springboard to get inside your environment. When we look at height as a deterrent, there are differences. 2 feet, a casual trespasser may stop him. 3 feet, some deterrent may occur. 6 feet or greater, a great effort is done by the trespasser to get over it. And there's also issues like barbed wire or electric fence. Now, electric fence can also act as a possible intrusion detection system, meaning that if somebody cuts the wire, because electricity on there, that would be indicated as central environment. In the picture here, what we can see, it's a low 2-3 feet wall. However, what the guys have done is actually extended that using barbed wire, as they have had problems as well. A very good example here is a correctional facility here as well. Right on top of the fence, which is number 2, turned inwards to keep the inmates in, we have blade wire or barbed wire. Then just outside the initial fence, we have palisade fence. And then finally, we have an external fence. However, there are weaknesses of the external fence. Although it's a small barrier, people can dig underneath that fence as well. We have controlled access points such as gates and turnstiles, smart cards and magnetic stripes. We have a man trap, where small or single entry or even large rooms. A man trap is a environment or controlled environment where a person would use a perimeter entry such as a smart card or a magnetic stripe card, open the first door, step inside the small room, close the first door, use the perimeter magnetic stripe card or smart card to open the second door, or it might even open automatically. This ensures that we have control from a guard room who enters and exits our environments. Also, bollards are used to ensure that we don't have anybody driving through without any authorized access. You see it sometimes in cities where bollards are put outside because thieves or people like to break into a shop, might drive through a window, commit the crime and leave. So they put the bollards on the outside of the shop. In this example, quite a heavy-duty bollard. It can be fixed or manageable, meaning that it's down at sometimes and the guardroom may raise it, or even automated where radio frequency ID tags may lower the bollard as a car approaches and raises again as a car leaves for parking environments as well. Now, when we look at gates as well, there's 4 types of gates that you need to consider. There's a class 1, which is least secure, which is residential use. We have class 2, which is commercial use where public is expected. Example, a parking garage or a multi-family housing unit. We have class 3, which is industrial use where public is not normally expected, such as a factory or loading dock. And finally, the most secure, which is class 4, restricted access, such as a prison monitored by closed-circuit TV, or even airport security areas as well. Now, when we look at gates, there's some key points to understand. That physical protection of gate should include one primary and one secondary device. Slide gates, including rear cantilever support area, should not allow a 2¼ inch sphere to pass due to the fact that reach-through injuries are the most common. For example, people putting their arms through it. No control should be mounted within 10 feet of a moving gate, of course, in the inside of the perimeter. Also, pedestrian gates should always be available. Cantilever rollers should be guarded, and warning signs should be affixed by the gate panel. That's my due diligence. Also, when we look at perimeter intrusion detection system, which detects unauthorized access to an environment, this can be passive infrared devices. You have pet-friendly devices, which, for example, a 9-kilogram heat signature, more than that will trigger and less than that won't trigger. Also, some of these devices, that needs to be tamper-proof as well. And there's an example is a variable resistor. There's two also modes of detection when we look at IDS here as well. Either objects moving, so if it's an office where nobody's moving and somebody walks in, it may detect them. Also, in an airport environment, they may have a camera which takes a snapshot of an environment when no person is in the environment. So it actually learns the environment. When people move in and out, it's fine. However, if a person walks inside, puts a bag down and leaves, so the bag is stationary as well now, so there's a new stationary object, it will trigger on that possible incendiary device. Now, this slide is not really important for the exam, of course, but it just shows you how it works. You either have one normally open or two normally closed intrusion detection device. These can be bypassed. Normally open, it could be that we cut the wire, so irrespective, it will never detect it. Normally closed, we can bypass the intrusion detection device, short circuit it in, will never detect it. However, if we insert a resistor, 1K, 3K ohm, doesn't matter, into the circuit, and the device learns what that circuit should look like, if anybody bypasses or cut it, it would be either resistance of 0 or infinity, and it will be triggered. So we cannot bypass that device. So it's tamper resistant. Also, when we look at closed circuit television, CCTV, you'll see some of the documentation refers to as 3 main components. What I've done is, well, looked at the whole process, and although it could be 3 components, there's one item excluded from that equation. And I define it as actually 4 major components. We've got the CCTV capability requirements, such as detection, identification, recognition, and these are all the requirements of CCTV in the environment. We've got video content analysis, such as database of size, speed, and color. A person running in the opposite direction of traffic flow will be detected. Mixing capabilities, infrared, in dark environments. We have to have special lights and special cameras for this. Visual spectrum as well, and also virtual dummy systems. Although it may not work, people see it and they won't commit any crime. So, as I said previously as well, 4 main components. We have the camera lens, zoom function. We have high definition capability of the latest cameras. We have white balance and auto exposure, so it will adapt to the actual light, the illumination. Is it low light at night, or is it sunrise, or things like that? There's also transmission media, one of the second components, such as wired or wireless. Now, IP-based 2.4 gigahertz with possible interference. Even your microwave, which runs at 2.45 gigahertz, may interfere with your wireless CCTV. There's a display monitor as my third component. And finally, my recording media, or the format, such as analog versus digital. Mostly it's digital these days, and it's also accepted in court due to the fact of it placing timestamps on the actual images, as well as secure hash signatures on those. There are also H.264 and other compression formats. Now, as you know, most probably H.264 is MPEG, or Motion Picture Expert Group compression. Now, also from CCTV functions, there are things like pan and tilt units. There are mountings to make sure that are protected from vandalism. There's switches and multiplexers to ensure that more than one camera can be recorded onto a stream, up to 16 cameras sometimes. Remote control camera controls. There's infrared illuminators to see at night when people think you're not watching them. There's time and date generators, which you need to make sure that they are from a reputable source for forensic evidence. Also, videotape or digital recorders, motion detection, also non-motion detection as well. Certain concerns that we can look at CCTV includes total surveillance. Sometimes are some cameras watching other cameras? Is it possible for people to bypass the cameras if they know where the dead spots are? Size, depth, height, width, where to place those cameras. Are they vandalism proof? Lighting, incorrect placement, either too bright or too dim. Contrast. There's also a problem with auto contrast, which can destroy the quality of the images as well. When we look at lighting, it should be used with other controls. It supports a crime prevention, and you have to have lights overlapping. You should not have any dark areas. Now, also a measurement. This is a little technical side, not part of the curriculum. However, a foot candle is a luminance cast on the surface by one candle source 1 foot away. However, recently lux is used rather, which is illumination per square meter. Now, just for the technical side, 1 lux equals 0.0929 foot candle, or 1 foot candle equals 10.764 lux. An example of a standard measurement at ground level, this was taken from a municipality as recommendations for the people installing the lights. We have a task or an area such as an active building entrance, average of 2 foot candle, not exceeding 5 foot candle. An approach environment there at the building entrance could be 0.2 foot candle. And the interesting thing here as well, when we look at public parking, the average should measure 0.8 foot candle. However, there should be a minimum of 0.2 foot candle. There's different types of lighting. There's continuous lighting, which is an array. This example includes lamps spaced evenly to create a wide area being lit, also known as an array, as I said. There's strip lighting, which is intrusion detection systems, also known as response area illumination. There's standby lighting, which creates an illusion of user activity. Emergency lighting, when a condition is met, certain lights are activated. For example, there could be a loss of power, a gas leak, and a gas leak could be a red or any other warning light. And also redundant or backup lighting in the case of a power failure. Building entry points include doors and locks. Now, when we look at doors must resist force entry. It's different types of doors. For example, there's hollow doors versus solid doors. Also, the hinges on the door should be tamper-proof. The door fire rating should be in line with the wall fire rating. If a door's emergency exit, it should be alarmed. So if it stays open for a while, it should trigger to a central environment or an audible alarm. Electrical controlled doors, such as fail-safe doors, which means that if the power fails, the door should open. Then you should, as a compensating control, use cameras and guards during that event. Also, access control, badge or perimeter devices at the doors are recommended as well. Different types of locks you can see. There's combination locks. You know what that is. As you can see from the picture there on top, there's deadbolt locks, which means that the lock actually goes from the door inside the wall or the door containment area to ensure it can't be picked. There's keyless locks and also smart locks as well. Now, also when we look at lock picking, it's also to consider that locks are pick resistant and not pick proof. And in some states or some countries, it's possible that a person is found in possession of any lock picking equipment, he or she will be arrested due to the fact that it indicates a person has been picking locks. Now, also when we look at the lock strength, there are different types of grades. There's 3 grades of locks. Grade 1, commercial industrial use, which is the highest strength. Grade 2, which is heavy duty or residential, or light duty commercial. And then finally grade 3, which is residential and consumer lowest security. Then each of these locks, you may have a cylinder category as well. Low, medium, or high security. Low security meaning no pick or drill resistant. Medium security means some pick or drill resistance. And then finally high security, pick resistance through different mechanisms, and normally using grade 1 and grade 2 locks. When we look at lock security controls, we need to consider things like lock and key control procedures. Who's got the keys? Who are allowed to open the device? Are they monitored? Key control procedures. Who signed for those keys as well? Also, lock combination must be changed. Failure to change the default combination. I've seen some Kingston locks on desk at 0000 as a combination. Now, often these Kingston locks are left on desk with open combination after hours, and it's easy for a perpetrator then to write it down and come later to steal any equipment like laptops, for example. There's different failure states you need to consider. There's fail safe, which means that when the power is off, suddenly the device is unlocked, or fail secure, when the power is off, the device is locked. The next section you need to consider about is the support, the implementation, and operation of internal security. This includes guards. Guards can provide a deterrent because they're visually there. Cognitive decisions, meaning they can make a decision if something is a threat or not. Also, different level of guards exist, such as patrolling guards alone, certified with arms or sidearms, certified with canine or dog units. And there are different types of guard stations. You have a central control unit or command center. Also, areas that need to be visited during rounds, which then the guard would use a button or control point to actually identify that he was at that control point. Electronic physical access control, we have card access such as hotel rooms, biometric access control methods, and they can be used along with PINs, centralized logging, possible download if you don't have centralized logging, and hopefully an HR interface, meaning that a person accesses is disabled when he or she is on leave. Then also clock synchronization of these devices for forensic requirements as well. The next section, we need to support the implementation operation of the facilities security, such as infrastructure support systems, electrical power. There's water that you need to consider. Gas lines. Some areas have got gas lines and you have may leakages. Heating and sewerage as well. Sometimes sewerage is not adequately designed in an environment like skyscrapers. Johannesburg is a very good example. Skyscrapers there, but the sewerage hasn't been designed to cope with those buildings. So it is a threat. Other key threats to support systems include fire, water, power loss, human-made such as strikes and sabotage. Now, when we look at fire prevention concerns, there are issues like we have to abide by fire codes, local fire codes. We can have fire containment systems on floors, on vents, and also the air conditioning. So if a fire breaks out in the one room, we should be able to lock everything down to make sure that the fire doesn't go or traverse to the other room as well. There are different types of fire extinguishing systems, such as permanent and mobile, and also part of the best practices, fire prevention training and drills should be done often. Maintenance, we should have service logs, annual service of these permanent or mobile devices, and also monthly inspection. Sprinkler system, we can have wet and dry, which we'll look at. And then also part of the best practices, testing should be part of the DRP and BCP. Fire protection, we have fire prevention, such as the removal of possible sources, no paper inside a computer room, for example, using fire retardant material, and also proximity hazards as well. Don't build your computer system next to a petroleum depot, for example. That's a consideration. Fire detection, we can have smoke detectors, which is ionization of air particles at certain smoke detectors will pick that up. Heat detectors, infrared cameras, and also in the olden days, wax melting. We have fire suppression such as self-extinguishing devices, and depending on the class of fire as well. When we look at this table here, there's the American and the European classification. We're going to focus on the American. A, common wood, paper, or plastics, and we can have a suppression agents such as water, foam, and dry chemicals. We have B, such as liquid, gasoline, and solvents, and also flammable gases as well. We can have a halon substitute, CO2, foam, and dry chemicals to combat that fire. Electrical fires, we have halon substitute, CO2, foam, and dry chemicals. D, which is combustible metals such as magnesium, sodium, potassium. Dry powders, usually equating to the actual metal as well. And then finally K, which is cooking media, fryers or grills, which is specialized wet chemicals as well. Now, when we actually look at type of extinguishers, looking at the US naming here, of course, we can have pressurized water, which is class A. Loaded stream, which is like pressurized water, however, with antifreeze added. So one of the biggest threats of pressurized water in pipes when it's a loaded system, that the water can freeze, and water expands when it freezes under 4 degrees Celsius, and that can crack pipes. We have foam, which can attack class A and B fires, carbon dioxide, class B and C, dry chemicals, we can attack class B and C types of fires, or even A, B, and C. And then finally, a halon replacement can do B or C, or all A, B, and C. And then finally, class D, dry powder, specific materials are targeted as well. Now, when we look at halon gas has been restricted by the 1987 Montreal Protocol. And the reason for that is that halon gas contains what they call a CFC, or chlorofluorocarbon, which supposedly attacks the ozone, which is O3. Now, many jurisdictions require removal of halon, and what you need to do, there's a replacement alternative for halon, and what you need to do is look at this, a couple of them, learn them off by heart, and see if they are mentioned, what they do as well. The most common one is, for example, the FM2 and Inogen. Its replacement, also water and CO2. The problem with CO2 is that it replaces oxygen, and also us as humans require oxygen, and that becomes a threat to humans. Now, when we have sprinkler system, we have wet pipe systems, or also known as a closed head system. It always contains water in the system. There's a dry pipe system where the water is not in the pipe but in the holding tank. There's a pre-action system. It's similar to a dry pipe system, but it's only released when pressurized air within the pipe is reduced. And then finally, a deluge system, which has a large sprinkler head for release of water, and normally not in data centers. Now, for example, we can have gas leakage as a threat. However, LPG or liquid propane gas has an additive to make it smell, so humans can understand that there is a gas leak happening. Water threats, which is where the most common failure includes air conditioning systems leaking on computer equipment, sprinkler systems leaking, then the loss of electrical power, where we can consider separate grids, and also the loss of heating, ventilation, and air conditioning, which may result in a meltdown of computer equipment as well. In this picture, we see left-hand top, high voltage transient lines feeding into the right-hand side here into a transformer environment, and then finally a step down at the bottom, middle, into a residential area as well. In this case, that's about 11,000 volts going into that transformer, being stepped down to 220 volts for residential usage. Now, also the type of power faults that we can get in electrical fault is things like power excesses. We can have a spike or a surge, power losses, a fault or a blackout, power degradation, interference, brownouts, can be intentional or unintentional, also a sag or a dip, which is short-term contra the spike, and also an inrush current as well. The next slide will show you some examples of a graph of that. As you can see here, the spike is identified. It's a little bit 10%, normally 10% more than the actual voltage. It would be 110 or 220 volts. You have a sag, a dip, which is the reverse of the spike. We have a surge. Now, surge, if you look at a spike or a sag, it's usually 1 to 2 nanoseconds as well. When you actually look at a surge or a brownout, it's a little bit more than 3 nanoseconds as well. Now, interference or noise, when we look at that, it can be anything where interference from electrical devices or so on. And then finally, a blackout or fault, which is no power at all. Typical noises we can have electromagnetic interference or EMI, which is caused by motors, lightning, and more. There are spark noises as well we can see. There's radio frequency interference or RFI, caused by components of electrical systems such as cables, fluorescent lights, vehicle ignitions, and some other types as well. When we look at common types of EMI, we can have common mode noise. This is a noise from radiation generated by the difference between the hot and the ground wire, and traverse mode noise, which is the noise from radiation generated by the difference between the hot and neutral wires as well. Now, to combat the problems with power, we have electrical power protection. We can have an uninterruptible power supply such as a UPS. We can have online, also known as double conversion, which is a power regeneration and always on. There's no loss in power supply to the main components in the case of the actual loss of power. There's offline or standby, where a fraction of a second to take in case of power degradation, and this is a cheaper option, of course. And then also you may have power line conditioners, which is also known as a line interactive. There's automatic voltage regulators or AVRs. It can be capacitor based, also MOV or metal oxide variocer based as well. In this following picture, there's an example of metal oxide varicers in a plug. As you can see here, between the live, neutral, and earth, there are each between those, there's a metal oxide varicer. And what that does, it will arrest high voltage and current. So if a sudden current comes through there, such as lightning, it will arrest that. In the right-hand side picture, you can see a catastrophic failure of a MOF device due to a lightning strike as well. Now, that device would be replaced, and hopefully anything beyond that would be protected adequately as well. A risk that we need to consider as well is static electricity in the environment. It is due to low humidity and types of material being used. We can prevent it by using anti-static flooring, anti-static carpeting, or certain mats. We can have proper humidity, and this is measured using a hygrometer. High humidity on the other side can lead to corrosion. Proper grounding In the olden days as well, if you can remember, you had anti-static armbands connected to a ground when you worked on computer equipment as well. Now, when we look at temperature, there's a safe operating temperature, and I usually say read the label. The more you can read the label, the more you'll remember it. There's an ambient temperature for computer rooms. As you can see from the graph here, the red dot or the green square indicates the design criteria. This is from IBM design criteria. And then also in the blue is the machine operating criteria. So what the design would be is straight within that machine operating temperature as well. Now, there's definitely different requirements for hard disk computers and network equipment as well. And when we look at computer equipment and temperature for a computer room can be anything from 16 degrees Celsius to 32 degrees Celsius, and also with a relative humidity of 45%. Now, this is just for the geeks out there. There's a conversion if you want to go to Fahrenheit to Celsius. We can take the Fahrenheit that give us, we subtract 32 from that, multiply by 5, divide by C, that will give us the Celsius. And at the bottom here, the example from Death Valley, 129 degrees Fahrenheit gives us 129 minus 32 is 97. The 97 times 5 divided by 9 gives us approximately 54 degrees Celsius. Now, also when we look at the environmental, we have to have ventilation in computer environments, in our data centers. Airborne particle limits must be measured, of course. We could have a clean room depending on what we do. Also, closed loop is a ventilation system where no new particles are introduced and the air is reused after filtering. And also positive pressurization means that in case the doors are open, air will flow out. The next section, we need to support the protection and securing of equipment. We can have compartmentalized areas. Extreme sensitive location where sensitive equipment are stored or sensitive information is processed. In this area, we have the stringent security controls where possibly photo IDs, biometrics, and verification of users are done as well. Multi-layered physical security access control. Very good example I've seen is in the Swift encryption modules at a company called BankServe between all the banks, which has access control in a passage, which has a time limit for you to go past. And if you don't go in that area, CO2 will be released, although there are CO2 masks inside that passage as well. Data center or server room security, we need to think about walls. We have a drywall. That's a gypsum board between paper or cardboard. It can be also used sometimes just for sound insulation. Temporary insulation definitely and gives us very low security. A firewall is a wall that is coming from the foundation at the bottom right through the ceiling, right to the roof to ensure that it protects adjacent rooms in a case of fire. And then also from server room security, we need to think about multi-factor access control, such as card access data center, biometrics, access computer room as well. Then computer equipment protection, computer equipment security, such as laptops and PCs, there are Kingston locks. We have server cabinets with possibly key control mechanisms as well. Portable device security, we can encrypt the data on there. We can have remote wipe in case of theft, also known as a kill switch. Data leak protection, DLP, and then objects placed inside security containers. This is for a courier transporting devices, and also if it's money, die packs in cash containers. So if this is stolen and the procedure is not followed, a device will explode, releasing the die, and it will stain the money. When we look at doors can be fire escapes, but should also be alarm enabled if they are fire escape, and should never be locked. Windows, none in a computer room, of course, and also if it's the side of the building and if people typing their password, it can lead to spying. Also, there are different types of glass we'll look at, and entry points within an environment may include threats like tailgating or piggybacking as well, and it should be used as an exit during an emergency as well. When we look at types of glass, there are standard glass. We have tempered glass, which is treated with heating and cooling cycles and could be 5 times or more stronger. We have acrylic glass or plastic, a type of plastic, which is toxic when it's burned. We have wired glass, which is 2 pieces of glass laminated with wire mesh in between. We have laminated glass with special rubber between or certain plastics to make sure it is bulletproof. We have solar window film, which is tinted to ensure that it protects the environment from heat or the radiation. And also finally security film as well to make sure that glass is shatterproof as well. And then finally, we need to understand personnel, privacy and safety. There are really privacy issues when we look at CCTV recordings. This should not infringe on privacy law in your environment. Actual law can never be overwritten or bypassed by policies, for example. Access to any of these recordings should be by authorized personnel only. And then you see something like the Data Protection Act as an EU directive. Only data required for a specific reason may be kept. All information should be removed if it's not required. Keystroke monitoring is really dependent on local laws. And finally, you have to consider local laws and bylaws as well. When we look at personnel safety, as life is the primary goal of physical security, fire escapes should be operable at all times. Design consideration using CPTED, as we saw before. Parking areas, underground, remote, walking to and from the office. Crime statistics in your environment. Are incidents logged? Staff working late? Let's look at possible company transport. Also, safety officers should be trained in security, and fire drills should be done as a requirement. Emergency procedures should include things like emergency shutdown procedures of equipment and data centers, evacuation procedures, employee training, awareness and required rules, periodic testing, and as said, employee training. Identify personnel should be accountable for these procedures. It must be documented and signed off, and definitely part of the BCP and DRP. In conclusion, physical security is a small section of the CISSP CBK, however, it's an important perimeter. Data center design using natural and applied controls was covered here. With the design issues, threats and control, it is more important to make sure that people do come first. This section is a very nice dovetail between DRP and BCP along with operation security. As it is the final domain within the CISSP CBK, I presume it's approximately 4 to 5% of the exam. However, focus a lot. Thank you.